are starting the circle. More exercise we are doing. What is the definition of the circle? We know. The locus of the point moves such a way the distance from the fixed point is a same, so constant. And what is the equation of the general equation of the circle? We know x is comma square 2gx plus 2fy plus c. And if it passes through the center, then c is 0. If it touches the x-axis, then its radius is equal to the y-coordinate of the center. If it touches y-axis, then its radius is equal to the axis of the center. Axis of the center. We know this. We have read previously how many the tangents drawn when the radius at more distance, when radius are more distance, and when touch how many tangents drawn, and when cross they cross how many tangents drawn. We have discussed previous time. We have also discussed the radical axis and the radical point. We also discussed what is the equation of the coaxial circle. What is the definition of coaxial circle? That circle having the same radical axis. And general equation of the coaxial circle is x square y square 2gx plus c, where y is the radical. What is the point when the point circle is there? What is their point? We know g square is equal to c, g is equal to plus minus c for the coaxial system of circle having the radius 0. We have discussed previously. Today we are solving some questions relating with the circles. Now first is if the equation of the any two diagonals of the regular pentagon belong to the value of the lines and their lengths are the sin 36. The locus of the center of the circle circumscribing the given pentagon. Pentagon have no side common in triangle formed by the diagonals with the pentagon. Now what is the we have to prove locus. This is the locus. Now you see the family of the lines we are given of the diagonal 1 plus 2 lambda y. Question number 1 plus 2 lambda y minus. Now what is the next? 2 plus lambda into x. 2 plus lambda into x plus 1 minus lambda. We are given this. We are given this is equal to 0. The family of the lines of the equation of the diagonals. Now we separate this. We have y plus 2 minus 2x plus 1 is equal to 0 and 2y minus x minus 1 is equal to 0. This can be written in this way. Take the y minus 2x plus 1 without lambda. We have this equation. These are the diagonals. We solve them. What we get? Multiply this with the 2. We have minus 4x plus 2 is equal to 0. Now subtract from the 2. What we get? We get this is cancelled out. We get 3x. Here we will get minus 3 is equal to 0. X is equal to 1 and y also 1. We have put the value of x is equal to 1, we get the value is equal to 1. The diagonals are like this. Pentagon are like this. You see, pentagon is this, ABCD. Pentagon, one diagonal is this, another diagonal is this. And what is the center? you see, what is the center? You see, center will lie on the diagonal. What is diagonal? Now you see, if you meet this, these are the equal to radius of the circle, circumscribing the pentagon. Let the R be this. We are given the length 36, sin 36, sin 36. Now what is this? This will be 144. This will be, we can find out with the help of the diagonals. This will be perpendicular, this will be 72. Now length is 36, sin 36 upon, we know half of this, half of upon R, this is equal to sin 72, you see here. If 72, this is perpendicular, 36 upon 2, and this is the hypotenuse. We have this. Now value of the R is sin 36 upon sin 72. This is the value of the R. This is the value of R. Now you see the radius. You see radius is this. Now what is this point? This is point 11. We can easily calculate the O be the center of circumscribing the pentagon. We know. Let this be HK. Now we are going to find out the locus. Now you see radius is this. Radius is this. Now we know what is this now, you see. Now sin 36, yes, sin 72. Now we have sin 36, we multiply cos 42 and sin 42, we have this, then what is this value? This is sin 36, here cos 72, here sin 144, we know. Now this is equal to sin 36, this is, therefore only cos 72 remain only. The radius is this. Now center we have taken h minus k, the locus is h minus 1 का whole square plus k minus 1 का whole square is equal to r square. This is the equation to the locus. Now we put here, generalize this by removing the hk by xy, we have this. So r is this. Now expand this, we have this. Now you see. Now we have required locus. This gives us sin square 72. This is the locus. What he asked us. This is the locus. Now I am again repeating. Now let ABCD be the pentagon. Let the circle is inscribing. Let HK be the center of the circle. Now we are given EC diagonal equal to sin 36. This is half, and this 72 angle. Then we can calculate the value of the R by this. You see here. you see here, sin 36 beta 2 upon r is equal to sin 72. Now multiply cos 72 and divide it, we have this. Sin 44 is again sin 36, this will cancel out, only cos 72 remain. Now r is cos 72. The equation will be locus this. Generalize this, remove the hk by xy, we will have this. This is the required locus, what he asked us. This is the proof to the question number 1. Now we come to the question number 2. A rhombus is inscribed in the region common to the circle this and this. Now we have to draw 2 circles, and we draw the rhombus in between the region which comes between the 2 circles. If the 2 vertices lie on the joining centers of the circle, then what is the area of the rhombus? Now you see question number 2. Now you see we have solved question number 2. Now you see your circle is first is this, having the center at 2, 0. This first circle is this, and the other is also having the center at minus 2, 0. Also will pass from this. As will cut this, will cut this. This is the second equation to the circle. Now region is this between them this. You see here. Region is this. Let it be A, it is B, C and D. The region is for the rhombus ABCD. ABCD. This is the region. Now what is this? Now AB is here 4 in length. Now what is this? Solve them. We have solved what we get. We will get 8x is equal to, if we subtract, we get minus 8x is equal to minus, this is equal to minus, we subtract this, you get this. And now what is the equation of the circle? Circle, now we said this will cancel out, we will get 0, x is equal to 0. Now put x is equal to 0, we have y is equal to 12. So we get y square is equal to 12. So y is equal to 2 root 3. Now this point is 0, 2 root 3. Also this point is 0, 2 minus root 3. The length is CD. CD, what is the length? This is the 4 root 3. Now what is the area of rhombus? That is 4 into 4 root 3 beta 2 means 8 root 3. This is the answer to the question number 2. Now I am again repeating. Now 2 circles having first 2, 0 center and second 8 minus 2, 0. Now they meet at C and D. The value will x come out 0. If you subtract this, we get minus 0, x is equal to 0. Now put x is equal to 0, we have the y is equal to y square 12, or y is equal to plus minus 2 root 3, plus minus. You see here, the length of the CD will be what? 4 root 3. Length of the AB is 4. The area will be this. 2 point lie on this rhombus, and this is also lies on the rhombus. The rhombus is this, whose one diagonal is 4 root 3 and other diagonal AB is 4. The area is 4 into 4 root 3 beta 2 means 8 root 3. 8 root 3. This is the area of the rhombus between the two circles. This is clear? Now we solve the question number 3. What is the locus of the point which moves such a way the sum of the squares of its distances from 3 vertices of the triangle is constant? Now you see. Let the locus be HK. What is the locus of the point? Which is equidistant from all the vertices of the triangle. Vertices sides of triangle. Suppose the triangle is x1, y1, x2, y2, x3, y3. And now take the distances and take the sum and put it equal to constant term. Now what we get, you see here, 3. Now we come to the question number 3. What is the locus of the point which moves such a way that sum of the squares of its distance from the 3 vertices of the triangle is constant? Suppose the triangle is x1, y1, x2, y2, x3, y3. Suppose. Now let's take the point, any point, let HK. The HK distance from all the vertices we find out first and add them and we put equal to constant. Then what result we get, you see here. You see here, let circle be this. Let triangle be this. Let this is x1, y1. This is x2, y2. This is x3, y3. Now let the pointer be HK, any point. Let any point HK. The distance from this will be h minus x1 square plus k minus y1 square. Similarly, all. 8 minus x2 का square plus k minus y2 का square plus 8 minus x3 का square k minus y3 का square. This is equal to constant k. Suppose this is equal to constant. Now we arrange this. What we get? You see here h square 3h square 3k square we will get first. Now what is the here constant? Twice h x1. Here we will get x2. Here we will get x3. And what is here? x1 square. We have x1 square from this x2 square, from this x3 square. Similarly with the y. Minus 2h y1 plus y2 plus y3. And here also y1 square, y2 square, y3 square. This is constant k. If you generalize hk, we have the required locus. This is the required locus, whose distance from all the vertices are equal. Oh, sorry, the sum of the distances is constant. We have put on, this is the equation. If we generalize, we get the locus. Because x1, y1 and x2, y2, x3, y3 are given to us. Because they are given vertices of the triangle. This is the locus. I am again repeating, no difficulty. Take the triangle, take the points, let any point be HK, whose locus we are going to find out. Now some distances are this. Distances are this. You see, what is the locus of the point? Squares. Then we have to remove this. Is constant, therefore we have the distance square of the distances is equal to constant. We arrange them and generalize them. We will have the required locus. This is the answer to the question number 3. Now we come to the question number 4. Then this is question number 3. We are going to now question number 4. A circle passes through point 1050, touches the y-axis at 0h. If angle ACB is maximum, what is the value of the h? Now you see, the circle be this. Suppose circle be, let the circle x square y square 2gx plus 2fy plus c is equal to 0. Let the circle be this. Now what is say? What is say? It passes through 10 and 50. It passes through 10 and 50. We have 1 0 2g plus c is equal to 0. We put 5, we have 25 plus 10g plus c is equal to 0. Subtract this, c will cancel out. We have -8g, we have minus 24. So g is minus 3. G is minus 3. And what is the c? Put the value of g. We have, what is the value of the c? 6 plus 1 minus 6 plus 1 minus 5. So c is equal to 5. The equation is x square plus y square minus 6g 6x plus 2f y plus 5 is equal to 0. Now this touches the y-axis. It means we put 0h in this. What we get? Put 0h. We get, this is 0. We have this is s square. This is 0. We have 2fy plus 5 is equal to 0. Now this touches the y. He said the angle ACB is maximum. It means this is gives the identical root of the h. Identical root of the h. This will go because they touches the. He says the ACB is maximum. Then d is 0. Discriminant 0. Then we have 4f square minus 20 is equal to 0. We have square is equal to 5. F is equal to root 5. Root for f gives us root 5. We take the one value. We have to take the value of the f1. Now put what this is, you see the h square plus 2 root 5 y plus 5 is equal to 0. This is plus root 5 ka whole square is equal to 0. Now you see here the h plus root 5 is equal to 0. We have h is equal to minus root 5. Therefore h value we have root 5. We have value of the h root 5. What he said? What is the value of the h? What is the value of the h? He say. What is the value of the h? He say value is root 5. You see here. We take the only positive value. We take the only positive value. Because this lies in the first quadrant, touches the y-axis and passes through this point. We have the positive value of the h only positive. Well, only positive, so therefore we get the h is equal to root 5. I am again repeating. Let the circle be this. This passes through 10 and 50. We have value g is equal to minus 3, c is equal to 5. I put this circle, we have this. Now discriminant should be 0 because we will have take the two coincident root. And ACB should be maximum. Therefore, discriminant 0, we have this, we have f is equal to root 5. We are taking positive value of the f. You see, this lies in the first quadrant. Now you see, because passing through these points and the 0, 8. Therefore, in the first quadrant, we have put the value of the f. And we question, we get this. Now from this we get the value of the h minus root 5. We have to positive value that this is root 5. This is the solution to the question number 4. This is the question number 4. This is the answer to the question number 4. We come to the now 5. What is the locus of the middle point of the chord of the circle? We subtend right angle at a beta 2 b beta 2. Now you see this circle, here the center at a beta 2 b beta 2. What we get here, you see here, we are solving question number 5. Now circle is this, and center is a beta 2 and b beta 2. Now what says he? What says? What is the locus of the middle point of the chord of the circle? Subtend right angle at the a beta 2. Now we have the chord, this, suppose this is chord. We are going to find out the middle point of this. Now you see, this subtend is the right angle. This is right angle. This is right angle. Now we will, this is also right angle. Now we know with this, let me the middle point be this, then this will be 45 angle. These are equal radius. So this is also 45. We have easily this distance and this distance we can have easily. Now what is this distance now you see? What is this now? The radius is now equal to a square beta 4 b square beta 4. Now this is 45. Now this is h minus a beta 2 का whole square plus k minus b beta 2 का whole square. This distance you see, middle point and the center, this is the distance perpendicular beta r. R is a square b square beta 4. This is equal to sin 45. Sin 45 means 1 upon root 2. Now this is the required locus. We arrange, we will get answer easily. Now you see, this is the radius of the circle. And this distance OM, suppose this is O, this is center is O, this is OM, is equal to this distance, and radius is this, and this is equal to perpendicular upon hypotenuse is equal to sin 45. This is 25 because both are equal angle. Therefore, this is 45. This is 90 degree. Therefore, this is 45. Now we generalize this. We will get the required locus. Now we have squared the both h minus a beta 2 का whole square plus k minus b beta 2 का whole square equal to 1 upon 2 a square plus b square beta 4. We have this. Now generalize this. We have x minus a beta 2 का whole square, y minus a b beta 2 का whole square. We have this. 1 upon 8 a square plus b square beta 8. Now we expand this. We will have a square beta 4, b square beta 4. Here we are getting a square b square beta 8. So only the plus a square b square beta 8 will remain. Not difficult. Now again repeating. Now take the circle, O is the center. Center is a beta 2, b beta 2. Now this radius is a square b beta 4, b square beta 4. C is not there, C is passing. So origin, because C is not given to us, so radius is this. And this OM, what is the OM? This is this. H minus A beta 2, K minus B beta 2. If M is HK, the middle point of the core, we have taken HK. This is taken from the center, this is. Upon radius gives the sine 45, we square, we get the required locus. 6. This is the tangent, equation to the tangent this circle. We know, we put the 0, 0, we get the value here, the perpendicular from J0 to. That is the radius of the first circle. It means this is the tangent to the first circle. And what about the second circle? It is also the common tangent. Therefore, this is also the tangent this. Then the center of the second circle, center of second circle is 3 root 3, 3 root 3 and 3. This is center. And draw the perpendicular from this on this line. What is the tangent? X cos theta plus y sin theta is equal to 2. Now put this, we have root 3 cos theta plus y 3 sin theta minus 2 is equal to, what is the coefficient? This is 1. This is given to the radius, equal to radius. What is the radius now? What is the radius of this? You see, if you make the square, we will get here 27. Here we will get now 3 9. Here we will, what we get? Here you will get 3. X square minus 6y plus 3, we get 9 minus 9. Now 36 minus in the minus, only 16 remain. The radius is 4. Radius is 4 of the second circle. Radius is 4, 16 comes there. You see here. You see here. This can be written in this way. X minus 3 root 3 का whole square plus y minus root 3 का square, and we will have to square this 27 minus here 9, we will get here 16. You see here. So therefore radius is 4. Now this is equal to radius 4. This is equal to radius 4. Now what he asked us, what is the value of the theta? He wants the value of the theta. What is the value of the theta? Now you see here. Now you see here 3 root 3 cos theta plus 3 sin theta is equal to 4, मतलब 6. Take the 3 common, we have this. Divide by 2, put this cos 30. This is value of the root 3, 30. 6 cos theta plus sin theta sin 30. Now this is 1. Now this is value theta minus pi beta 6. Here we get 1 is equal to cos 1 is equal to cos 0. The theta minus pi beta 6 is equal to 0. Theta is equal to pi beta 6. This is the required answer. Now I am again repeating. Now this equation is tangent to the first circle. We have proved the distance from 0, 0 comes out to. And for the, what about the second circle? We have the distance from 3 root 3, from this we have this distance. This is equal to 4 because second circle can be put in this way and we get the radius 4. You see here. Now we get this. Put the value of the center, we get this. Now divide by 2. we get this. This formula of the cos theta minus pi beta 6. Now this is equal to 0 because here 1 comes means cos 0 comes. Therefore, the value of the theta is equal to pi beta 6. This is the answer to the question what he asked us, which is what the value of theta. Theta's value is pi beta 6. Now we come to we have solved the question number 6 here. Now we could solve the question number 7. If the points A, B and C lie on the circle, what is the locus of the ortho center? Now circle is this. Now we are solving the question number 7. Now you see circle is this. And this passes through 1 0 0 0. Therefore, this is 1 0 and this is 0 1. Because circle is, what is the circle? This is the circle x square y square is equal to 1. Therefore, they will meet at A 1 0 and at B 0 1. And take the another point C. Suppose C is here. This is cos theta and sin theta. This is suppose this is on the circle. We can have r cos theta, r sin theta, r here r is 1. Therefore, cos theta, sin theta lies on the circle. Now take this. This is the circumcenter. This is the center of the circle. Therefore, origin also. This is center of the circle. We know this is this is the center of the circle. Therefore, we know that G. If we take the G, then G divide the line OC. Then in the 1:3. If we are G is here, suppose this is triangle. This is triangle. Suppose this is suppose triangle. Then also the center will lie on the OC, and G will divide into 1 into 2 ratio. Now what is the ortho center? Let the ortho center be HK. He wants the locus of the ortho center. He wants the locus of the, what is the locus of the ortho center? Suppose ortho center, we know G divided in the ratio 1:2. We can easily have 0 into suppose ortho center HK. Then H into 1 K into 0/3. This is the ortho center. Here also K into 1 plus K into, we have the value H into 1 and 2 into 0. 2 into 0. Similarly, we have K into 1 plus 2 into 0/3. This is the also the centroid. This is also the centroid. But centroid is this. What is centroid? We know 0 plus sin theta plus beta 3 and 1 plus sin theta plus 0. Here is 1. Here is 1 x command 0 and value of the here x command cos theta here is 1. We have this. We have this. Similarly, we have this. This is the centroid. But we have calculated centroid this. Then we generalize we will get the required locus. Now, what is this? Now you see here. Now you see here. So h is, now we get h is equal to 1 plus cos theta, and we get k is equal to, the equation we have this, plus sin theta. Therefore, h minus 1 square, k minus 1 square is equal to sin square theta, cos square theta is equal to 1. This is the locus. 1, x minus 1 ka square plus y minus 1 ka square is equal to 1 we have. This is the required locus. I am again repeating. Take the A, B, C, 3 points. C is on the circle. A and B also on the circle. Then the centroid will be 1 plus 0 plus cos theta plus 1 beta 3. And the other point will be 1 plus cos sin theta upon 3. This is the centroid. Now centroid divide the line joining the center and the outer center, divide the line into 1:2. Now we have centroid ortho center like this. Ortho center, from ortho center we can find out the value. We have h beta 3. This is equal to 1 plus cos theta beta 3. मतलब h is 1 plus cos theta and k is 1 plus sin theta. Now generalize this, take this 1 to the right and left hand side, we square and add, we will get the required locus. No difficult at all. We know that in the triangle, the ortho center and the central line on the same line, and centroid divide the line in 1:2 ratio. So therefore, we can find out the ortho center. And we now they put this is equal to for the centroid we have this relation. We generalize this, we will get the required locus. This is the solution to the question number 7. Now we come to the last question. If the chord of contact of tangent from a point P to a circle passes through Q, circle on PQ as a diameter cuts the given circle, now we prove this. The chord of the contact of the tangent from a point. Now suppose this is the P, tangent are drawn to the circle. Now chord of contact this. Now what is the circle? What is circle you see here? This is the circle we are given. The chord of the contact tangent from the point P to a circle. So suppose the circle is x square, y square, h square. We take the simple equation of the circle, this. Now what is the chord? What is the chord? Suppose P is x1, y1. Then chord of contact is xx1 plus yy1, 1 is equal to h square. Now this passes through Q. This passes through Q. Then we have x1, x2, y1, y2. It passes through Q. Then y1, y2 is equal to h square. We have this relation we have. Now we know equation to PQ is diameter. Equation circle PQ is diameter. We have the point R here x2, y2. Q is x2, y2. Therefore, the equation will be of the circle will be this. this will be the equation. Now what is this now? This is x square minus x plus 1 plus y square minus y plus y2 plus what we get here? We get here x1 x2 plus y1 y2. We will get this. This is the equation to the circle. x1 y1 x2 y2 is a diameter. This equation will be this. Now if this cut orthogonally, then twice G1 G2 is equal to C1 C2. We know if orthogonally cuts, then twice G1 G2 we know. It's got C1 plus C2, we know this formula. Now put the value. Now what is here? Here is G command 0. Here x1 x2. So 0 into x1 plus x2. Here 0 into y1 plus y2. Here what is the C? Here is the C a square. And what is the C? Here x1 x2 plus minus y1 we have this. We have this. Now we get 0 here. We have here x1, x2, y1, y2 is equal to a square. This is the same thing as the first. This is the same thing as the first. Hence just cut the circle orthogonally. If we draw the circle as a line PQ as a diameter, then they will cut the given circle square orthogonally. Now I am again repeating. Take the point P x1 y1. The corner contact will be this. This passes through the point Q x2 y2. We have this equation. Now the x1 y1 x2 y2 as a diameter, the cycle will be this. x1 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 x2, the y y1 y minus y2 is equal to 0. Now you see, if they meet orthogonally, then 2 as G1 G2 plus f1 f2 is equal to C1 plus C2. Here C is minus a square. Here is x1 x2 y1 y2. Therefore we have this is equal to 0. We have second relation. First relation, what he say? This says that the circle drawn as a PQ as a diameter, they have cut the given circle orthogonally. This is the proof of the solution to the question number 8. We will take next day.